This video is for Homework and Mastery 2.6, Section 20.1 in your textbook, Compound Inequalities. What we're going to look at here is solving inequalities that are compound, meaning they are combined with either the words and, or they're combined with symbols themselves. A compound inequality consists of two inequalities connected by the word and or the word or. When we solve these, the word and means that the inequalities both have to agree. They both have to be parts of the solution. The word or means when either one of them will work. That's part of the solution. Let's look at some examples. Graph the values of where x is less than or equal to 4 and x is greater than or equal to -3. So this means anywhere where it satisfies both x less than or equal to 4 and x greater than or equal to -3. We want to graph these values in between is basically what we're looking at. So less than or equal to -4, that means we're going to have a closed circle at 4 and go less than. At -3 we're going to have a closed circle and go greater than. So we're looking at between 4 less than, but it has to be greater than -3. So we shade in between these two numbers. And this satisfies our inequality x less than or equal to 4 and x greater than or equal to -3. This one is a combined compound inequality where there's not the words and or, but it's an understood and. It also means that the x is between these two numbers. Graph the values of x where -8 is less than or equal to x, which is less than or equal to 3. So we want to know that something is where x has to be greater than or equal to -8, but it also has to be less than or equal to 3. Because remember, when we look at this on the left-hand side, right here, we have to think about it in the reverse order. X is greater than or equal to -3. So we need to look at where they're in between -8 and +3. Notice that they both have the equal to portions, so they're both going to be closed-in circles, such as we have here, between -8 and +3. Here's another one where -2.5 is less than or equal to x, less than or equal to 2. So we want to know the values of x that is where x is greater than or equal to -2, but it is less than 2. Notice that it is greater than or equal to the -2.5, but it's only less than 2. So we're going to have a closed circle at the -2.5, but an open circle at the 2, as we see here. Notice it's an open circle at the 2 and a closed circle at the -2.5. That's because the 2 does not have the equal to portion. Graph the salary ranges of the full-time employees of Honey Bees. Each person earns at least $210 weekly, but not more than $500 weekly. Okay, so at least $210 weekly means greater than or equal to $210, but not more than $500 weekly. So that will mean less than or equal to $500. So we set up those two inequalities. Our salary is greater than or equal to $210, but it is less than or equal to $500. Notice they both have the equal to portions. So when we graph it, we're going to have both equals closed circles at 210 and at 500, and then shade in between. The solution of a compound inequality using the word OR includes all numbers that belong to either of the two inequalities. It doesn't matter which way it goes, it could be either or. So we want to graph the region where x is greater than 4 or x is less than -3. X can be greater than 4 or x can be less than -3. This includes all values to the right of 4 and to the left of -3 on the number line. So we go to 4, we have an open circle because it's strictly greater than, and we shade to the right. We go to -3, we put an open circle, and we shade to the left. Since it says OR, this is our solution, because it can be either one. Here we want the region where x is greater than -1 or x is less than -4. So we're going to put a circle at -1 and a circle at -4 and shade. Notice that there's a shaded circle at -4 because it says less than or equal to, and an open circle at -1 because it is strictly greater than. Male applicants for the state police force in Fred's home state are eligible for the force if they are shorter than 60 inches or taller than 76 inches. Graph the range of the rejected applicant heights. So if they're ineligible for the force if they're shorter than 60 or taller than 76 inches, that means they have a height less than 60 or a height greater than 76, and they're not eligible. So if we want to graph this, we say at 60 inches or less, and at 76 inches or greater than. Either way, they're rejected. Here we want to solve for x and graph the compound solution. Notice that we don't have x by itself on either inequality. Therefore, we have to first solve the inequalities for x. So I'm going to look at 3x plus 2 greater than 14, and I have 2x minus 1 less than -7. I'm going to first solve 3x plus 2 greater than 14. I need to subtract 2 from both sides, and I'll get 3x is greater than 12. I can then divide both sides by 3, and I get x is greater than 4. Notice I did not reverse my inequality because I did not divide by a negative number. Now let's solve the other inequality. 2x minus 1 is less than -7. I need to add a 1 to both sides, and I get 2x is less than -6. I'm going to divide by a positive 2, and I get x is less than -3. This means that the solution is x less than -3 or x is greater than 4. So whenever I graph this, it can be either or. Anywhere less than -3 or greater than 4. Notice that they both have open circles because neither one of them started out as equal to. Here's an AND. Solve for x and graph the compound solution. We have 5x minus 1 greater than -2, and 3x minus 4 is less than 8. So again, we want to solve each inequality separately. So I'm going to add 1 to both sides of the inequality for 5x minus 1 greater than negative 2, and I'll get 5x is greater than negative 1. I will then divide both sides by 5, and I'll get x is greater than negative 5. For 3x minus 4 less than 8, I'll add 4 to both sides, and I'll get 3x is less than 12, and I'll divide by 3, and I get x is less than 4. So the solution has to be x is greater than negative 5 and x is less than 4. So it's between negative 1/5 and 4. But remember, it's not including the endpoints because it does not have the equal to. So whenever I graph it, they both have open circles. Another example is x plus 3 less than or equal to 7 and x minus 2 less than or equal to 3. Whenever I start solving these equations, I get that x is less than or equal to 4 and x is less than or equal to negative 1. And whenever we want this to overlap, notice that the purple line is for x less than negative 1. It starts at negative 1 and goes left. The red line starts at 4 and goes to the left because that's for x less than or equal to 4. We want to combine these two for an AND statement. The AND statement is where they overlap. Therefore, my solution would actually be strictly x less than or equal to 1. Because this portion from negative 1 to 4 is not included, where they both are correct. It is only correct for x less than or equal to 4. But anything x less than or equal to negative 1 would satisfy both equations, both inequalities. Therefore, the solution is x less than or equal to negative 1. It has to make both inequalities true at the same time. If we solve this inequality, we have negative 3x minus 2 is less than negative 5, and 4x plus 6 less than negative 12. So I start solving, and I add 2 to both sides, and I get negative 3x is less than negative 3. I divide by negative 3. Remember, when I divide by a negative, I switch the sign or reverse the sign, reverse the inequality, and I get x is greater than 1. On the other inequality, I'm going to subtract 6 from both sides, and I get 4x is less than negative 18. Divide by 4, and I get x is less than negative 4 1/2. Where would x be greater than 1 and x be less than negative 4 1/2? It's not possible. A number that would satisfy both of these is not possible. So there's not a number that is greater than 1 and less than negative 4 1/2 at the same time. This compound inequality has no solution. There is no solution for this inequality. So you have to be careful. The word AND means that it has to be true for both statements at the same time. The word OR means that it can apply to either one or the other or both of them, where either one of them are satisfied. Remember again, while you're solving inequalities, if you divide or multiply by a negative, you must reverse the inequality sign. If you need any help, please let one of us know.